The objective of this topic is to list the purpose and applications of the low hydrogen electrode. When the coating of an electrode is consumed in the welding arc, it produces a slag and gas which shield the arc and the weld from the atmosphere. The molten metal absorbs some of the gas, which is mostly expelled as the metal solidifies. Some hydrogen gas is produced during welding. If any of it remains entrapped in the solidified metal, it can in some instances cause weld metal or base metal cracking. This problem led to the development of a type of electrode known as a low hydrogen electrode, which, as the name indicates, produces a low quantity of hydrogen gas during welding. And because of this, less hydrogen gas is trapped in the weld metal. Low hydrogen type electrodes are being used to weld a variety of metals, such as mild steel, medium carbon steels, low alloy high strength steels, nickel steels, quenched and tempered steels, chrome moly steels, and even cast iron. The main advantages of the low hydrogen electrode are reduction of bead cracking, improved ductility, improved low temperature impact strength, improved mechanical properties. Low hydrogen electrodes allow welding of metals that were previously considered hard to weld. They are replacing some plain carbon electrodes, and in some cases they are replacing stainless steel electrodes, which were often used for the hard-to-weld metals. When using low hydrogen electrodes, it is important to select the proper electrodes for the job condition. The EXX15 series electrode is used with direct current electrode positive. The EXX16 and 18 series electrodes are more popular and may be used with either alternating current or direct current electrode positive. These electrodes may be used in all positions: flat, horizontal, vertical, and overhead. When welding in the vertical position, uphill travel is used. Do not use an up and down or back and forth whipping motion with a low hydrogen electrode. This can cause slag to be trapped in the weld. These electrodes have medium penetration characteristics, and this requires extra precaution when welding a root pass with a root opening, since there is a tendency to trap slag or to produce porosity. Whenever possible, use a tight root opening to deposit the weld. After welding, the root pass is back gouged down to the point of sound weld metal, thus removing any slag or porosity that may exist. Then a back weld is deposited on the root side of the joint in order to produce complete joint penetration. If an open root joint must be welded, consider using an E7018 electrode or gas tungsten arc welding for the root pass, and then complete the weld with a low hydrogen type electrode. Pinholes or surface porosity are usually caused by incorrect arc striking, chipped, flux coatings, moisture in the joint, or damp electrodes. To avoid pinholes when striking the arc, strike just ahead of the starting point and quickly shorten the arc to its proper length, and then back up to the starting point and proceed over the strike area. Undercutting is sometimes encountered on fill and cover passes. To avoid this, use a Z weaving motion, pausing just long enough on each side to fill the undercut areas. Also, hold a very short arc length and avoid too high a welding current. In the flat, horizontal, or overhead positions, it is best to use a stringer bead technique. If the bead becomes too large, use a smaller diameter electrode. On multiple pass joints, be sure to completely remove the slag before each new pass. Like other kinds of covered electrodes, the low hydrogen electrode is easily damaged by rough handling and are very prone to moisture pickup. Before you weld, inspect the electrodes for chipped flux coatings. This will not only cause pinholes in the weld, but will also produce an erratic arc and hard zones in the weld. Also, look for evidence of moisture on the flux coating, such as stains or a damp feeling. If the electrodes are lightly tapped together, they should produce a hard clicking sound. If the sound is more like a dull clunk, the electrodes are damp and are not ready for welding. Electrodes must be stored in sealed containers in a dry environment to prevent damage by moisture or humidity. Special storerooms should be used, equipped with a dehumidifier to keep the relative humidity at 40% or less. Once the sealed container is opened, the electrodes should be stored in holding ovens, reserved especially for the low hydrogen types, and not mixed with other types of electrodes. These ovens should be maintained at a temperature of from 250 to 450 degrees Fahrenheit. Electrodes that have been exposed to moisture can be reconditioned by heating in an oven for about an hour at 500 to 600 degrees Fahrenheit. The maximum temperature is 800 degrees for no more than 30 minutes. Electrodes should not be reconditioned more than 3 times. Reconditioning weakens the binder that holds the flux coating to the wire, and the coating will chip or flake off. As a basic precaution against moisture and humidity damage, do not remove more than a 2-hour supply of electrodes from a sealed container. In addition, if the joint is damp, apply heat with a torch to completely dry the area of the weld. Do not weld on surfaces covered with oil, water, dirt, paint, and so forth. In review, the main precautions to remember for using low hydrogen electrodes are: maintain a short arc length, never weld with a whipping motion or in a downhill direction with multiple pass joints. Always clean the slag completely off after each pass is deposited, and keep the electrodes dry.